Assalamu alaikum and good morning. Today we're going to discuss our lecture on applied physics. So today we'll be discussing more of your issues regarding applied physics. Yes, Spring 2020 and chapter number 26. Okay, in chapter number 26, the things that we're going to discuss is share screen. This one. Okay. So chapter number 26 is about current and resistance. So mainly we will do some selective study. We won't go through each and everything, but the important articles, some of them I have already listed here. Okay, this is chapter 26. This is the first one. This is the flow of electrons through a conductor. That is current, resistance. We have to discuss. First of all, we have current density, current directions, conventional and electronic current, etc. So we will go through one by one. This lecture isn't very long, but we'll discuss the main ideas in this chapter. Okay, so you guys are listening. Share screen. Okay. वालेकुम अस्सलाम बच्चे आवाज आ रही है सबको? Good. Okay, so first of all in this chapter, you guys will go through the chapter, one by one. Share screen. Okay. This one. So you guys can see and hear me clearly. अच्छा आप सबको अब आवाज भी आ रही है और नजर आ रहा है, नोट्स भी नजर आ रहे हैं? Okay, that's good. So in the first half of this chapter, so we will go through this chapter, article by article. So first of all, we have current. What is current? Current is actually the rate of change of electrons through a specific point or cross-sectional area in a conductor. So mathematically, we define it as I. Current is equal to rate of change of the charge per second, dq by dt. So if we move dt over this side and dq on remain in this side, and we change, upgrade the equation, we get integral dq total charge, we're integrating for total charge, is equal to integral I dt. So this will become q, total charge is equal to integral charging from 0 to t and I dt. So the unit for charge is ampere, and in terms of time we have 1 coulomb per second. Okay, so this is our article, flow of electrons through a conductor. How charge flows through a conductor and creates a current of electrons. So current directions, a conventional current or electronic current. So conventional current is actually the positive current in a direction opposite to the current of electron. However, the electronic current flows in a conductor opposite to the positive current. Okay, conventional current and electronic current have opposite direction in the circuit. Remember this thing. This is very important. I'm telling you, this is very important, that conventional current and electronic current, they have opposite directions. Opposite directions. You can write it down, opposite directions. Okay, current density J is defined as the current per unit area. Current per unit area. So since from this equation, I is equal to J dot dA, and integral, we take integral. Current through a cross section will be integral J dot dA. I integral J dA, and the angle, because J is constant, we take it out of the integral, and integral dA is the cross sectional area. So area becomes capital A, small d A to A. So I is equal to J A, and J becomes equal to I over A as the in the definition. So current density is equal to the current per unit area, current flowing through per unit area. That is current density. Then comes drift speed. Drift speed is actually from the word drift, as you have seen the cars in a movie drifting. They drag along the road and then they make drift. And the drift velocity is in the order of 10 raised to power minus 5 and 10 raised to power minus 4. So charge carriers in a length L of a conductor, we have Q is equal to N number of charges, A cross sectional area, L length, and E is the charge of the electron. So T is equal to, from the equation, S is equal to Vt. T is equal to length covered over the velocity. So length over velocity or distance over velocity, you can write L over Vd. So T is equal to L over Vd. So we can derive the relation for the drift velocity. Okay, and the second one page is this one. Okay, yes, this is the one. So I is equal to, since I is equal to Q over T, I would be equal to, we put the value of Q and T from previous relations, NALE over L over VD. L cancels with L. So NAE VD. And I over A is equal to J. So I over A is equal to J. And this comes in the denominator NE. I over A becomes J. NE over here. So J is equal to VD NE, or NE into VD. So the current density J is equal to NE, total number of charges, into the charge of electron into the drift velocity VD. So this is the relation from this. VD is equal to J over NE, and J is equal to NE into VD. Okay, all of you are listening? बच्चों समझ आ रही है? This is very important article from chapter 26. I'm telling you, this is very important article from chapter number 26. Electric current and resistance, etc. Okay, then we come resistors and resistivity. These are the important article. Okay, what is resistance? It is the opposition to the flow of electric charges. Resistance, these are the basic definition, but you have to go through the chapter as well. You have to read the concepts as well. What is resistance? Resistance is opposition to the flow of electric charges. And resistivity, it is a measure of the resisting power of a specified material to the flow of an electric current. Resistivity, it is a measure of the resisting power of a specified material to the flow of an electric current. Yes, for example, the resistivity of 1 meter cube of iron will be same in Pakistan, in Australia, in USA, in Europe, in every part of the world. It remains the same. However, resistance of a material may vary from place to place. Okay, so when the material is changed, the dimensions is changed, the resistance changes. However, resistivity for a specific length cube, it remains the same. Who is this guy who is doing annotation? Stop is doing this annotation. Why you guys are putting these, Muhammad Amir? Who is the guy who is doing this annotation? Don't do this. Don't repeat this. Okay, resistance resistivity, as we know that V is equal to IR, and from this relation R is equal to V over I from Ohm's law. So 1 ohm is equal to 1 volt per ampere, and rho is equal to E over J, current density, J, E electric field, and rho is our resistivity. So resistivity is equal to E over J, and in terms of unit, it becomes E over J volt per meter over ampere per meter square. Meter cancel with meter and it becomes volt per ampere into meter and it becomes ohm meter. Okay, ohm dot meter or ohm meter. So E is equal to rho into J. From this relation, E is equal to rho into J. Sigma is 1 over rho. Conductivity is reciprocal of resistivity. So E is equal to J over ohm. We put this value in this and we get J over sigma. So J is equal to sigma into E. So J becomes sigma into equal to sigma into E. So this is the value of current density in terms of electric field and conductivity. Resistance is a property, we can say. Resistance is a property of an object. However, resistivity is a property of a material. Resistance is a property of an object, while resistivity is a property of a material. So from this, we have E is equal to V over L and J is equal to I over A. So rho is equal to E over J and V over L, I over. Walaikum assalam. What's up, क्या हाल है? I over L. So we can simplify. अच्छा थोड़ी देर में आए. घूम के आए तो. Okay, so this is the lecture for today. You guys can go through it and you guys can read about this lecture as well. I show you the slides. Okay, so here you guys can see these are the slides. Wait, huh? Okay, new share. This is chapter 26. So when you read, you will read a lot about the concepts. These are the diagrams involved in the derivation. You guys can derive from here. You guys have simplified solution over there. So the notes will help you, and we will also go the microscopic view of Ohm's law. This is very important. Superconductors, semiconductor, these are also important articles. So we'll go through these articles as well in the next lecture. So till then, take care, Assalamu alaikum and Allah Hafiz.